All right, hello and good morning. This is a video on how to navigate the master assembly and how to gather some information from it. So we're going to start from scratch here so we can all get going. So as always, we start with our GrabCAD. Make sure we have the most up-to-date Rocket files. So as you can see, I'm up to date on both sides, local folder and workbench. If I had parts to upload, it would show on this side as blue. If somebody had made some updates for me to download, it would show up blue here. As you can see, I just did this 20 minutes ago. So you're going to open up this GrabCAD program, go to your local folder, open folder. Now this is your local folder that has all of the files for the 10,000 foot rocket. So you need to set this up in your GrabCAD, but once you have set this up, you can see these are the projects that I have. So now we're in 10,000 foot rocket. These are the different subsystems. We've got commercial off-the-shelf parts here. So this is like fasteners, electronics, other garbage. It is classically messy, but there's some good stuff in here. So have a peek if you're interested. This is aerostructure. This is where we're at. This is where we got our stuff here. We'll get into this later, that's okay. But more or less at the end in this parent folder, we've got the rocket master assembly here. So classic SolidWorks, there's a million ways to do things. You can just right click and open, and it should open your SolidWorks for you. Hopefully. You can also open SolidWorks and drag it in. It's a nice, easy way of doing it too. It's going to take forever. Great. Oh, there we go. Okay. So I'm opening up SolidWorks 2021, 2022. And a couple things are going to happen here. First off, there's some missing components. Secondly, there's a couple of mates that are problematic. So you'll see here right off the bat, we've got a file that's missing from this user. So that's okay, we don't need it. We can suppress this component, and another one pops up from the same user. That's okay, we can suppress it. Right now, we're just worried about the main rocket. So yeah, little warnings here. There's an error. There's a mate error. That's okay, we don't care. We also don't care about this. If you don't, you can also click do not show again. You can go back and change that in settings, but that's okay. And we're not going to do saving. We're not going to save anything at all because we're just going to be pulling information from here and looking around. So here we go. There's our master assembly. By holding the scroll wheel, we can rotate it, and we can zoom in with the scroll wheel as well. And of course, we can hit our space bar and go to a view of the side like this. As you see, all of these edges are kind of dull. You can't see any of the edges like you normally would with a part file. You can change that just up here in your display style. Right here, it's set to shaded without edges. And if you go back up to the shaded with edges, you can now see all of the lines. The reason we don't do this is because, or we have this off, is because it's a little bit easier on the graphics, but I like to have them on because it's helpful. Anyway, so this is our main assembly. This is an assembly file, which is different from a part file. But the biggest thing, the biggest constant for all of our SolidWorks needs is this project tree. And this shows us all of the stuff inside this assembly. So for instance, we've got the propulsion assembly here. We've got the upper fuselage, lower fuselage, recovery assembly. And as you can see, as I'm selecting these things, they're popping up as blue. And there even has a little box around it, so you can see what I'm selecting. So this shows that you don't need to even look at your model to go find what you want. So let's do one that I'm familiar with so that we can start with somewhere easy. So the nose cone assembly is right here. I'll zoom in a little bit. Now, there's lots going on here. There's obviously the magpie inside. There's the recovery stuff. There's this parafoil, excuse me. Lots going on. But so we don't necessarily need to be seeing all of this extra stuff, and especially not all of this stuff because we're not even on the side of the rocket. So what we can do is we go back to our project tree. If you have a whole bunch of stuff open and you're really far down into here and there's so much to go through and you just can't really see at all and you don't want to go and click all those things, you can just right click on this space here, the gray space, and click collapse items. Sometimes it doesn't work. Sometimes you have to click on a file and then go and try and find collapse items inside this, and then it works. But regardless, collapse items will bring you back to this sort of collapse state, which is a nicer state to deal with. So anyway, back to our main issue here, the nose cone assembly. This is what we want. This is what we want to say, get the diameter of, but there's all this stuff in the way. And we also want the length here. So we're gonna go into our project tree, right click, a whole bunch of stuff comes up. What we want is isolate. This one right here, it's near the top. And when we click this, it's going to isolate the nose cone from all the other stuff in the assembly. So everything else here is now hidden, which is great for us because we just care about the nose cone. This is good. So now we can look at it, we can move it around, we can do all the same stuff that we could before. But we don't have to deal with all the other stuff in here. So now that we have this stuff, we can drag this away here. This little box popped up, which will show that we're in an isolated state. Put this somewhere handy because we'll get out of this later and you'll see. So say that you want the diameter here. How do we do that? So because we're in an assembly, not a part file, we've got a couple extra options here. We've got evaluate, this tab here. So we've got assembly, layout, sketch, markup, evaluate is the one that we're interested in here. This tab has a couple of neat features that we're going to use. The primary one right now is the measure. So you click this measure button. This little window will pop up. You can click this down arrow. Sometimes it likes to set things by default, kind of funny. So you can just hit the down. I don't know what that does. Oh, I think that just pins it down, which is nice. I don't know. I like to leave it down so that I can see it where it pops up. Anyway, once you've got this window open, back to your cursor space, you can see that now my cursor is a ruler and a tape measure, which is what you use to measure things, I suppose. But now we can measure things like diameter, length, distance. So watch this. I just click on this and all this stuff pops up here. Drag this down a bit so I can see a bit more. But we've got lots of things here. So first off, area, cool. Perimeter, awesome. Diameter, that's what we want. 4.51 inches. So when you do this, you have to make sure that you know what you're actually measuring here because there's lots of holes. If I accidentally click this edge here and then, I thought I clicked the diameter and I go back here and say, okay, cool. 0.7 inches diameter, awesome. And then I go and do a bunch of calculations and it's all wrong. So you got to make sure you know what you're clicking. Okay. And then to be more specific, you could go in and select this edge. Oops, this edge. The edge isn't well. There we go. Sometimes the interpolation for the graphics is a little bit chunky, so not ideal. But you see here now we have the same diameter, and it even shows that it's pointing at this edge, so we know that's this edge. So sweet, great. Say we want the diameter of this edge. But you see there's all this other, you see how it's sort of translucent? That's kind of inconvenient. So what we're gonna do is close this measure tool for a moment. And we're gonna click on this surface. When you click on a surface in SolidWorks, it brings it up in this project tree here. And you can see it's got lots of things inside it. This is also another assembly within itself. This hierarchy of assemblies is important to understand, but it's pretty intuitive, I suppose. So back to our issue of too many lines and translucency. If you right-click this box, or right-click this part. Remember, there's lots of ways to do things. So you can do it here. You can left-click and slowly hover up to the right. You can also right-click, and then this stuff pops up at the top. You can also right-click this one. I think you can also left-click this one. Yeah, you can also left-click this one. And then that box, but you can only do it once, right? Or you do it twice, you can change the name, but don't change the name. So anyway, I'm gonna do the left-click, wait, and slowly move my cursor over. And then I'm going to change this transparency. Now it's a solid nose cone. Now that's a little bit nicer, more realistic, of course. But if you're trying to make sure you get the right edge, so we're going to go back to our measure tool up here. If we really want to make sure we got that right edge, we can make it not translucent anymore, and we can go and get this other edge out here, 4.66, which is the same, which should be the same as the fuselage diameter, because this nose cone is tangential with the upper fuselage. So, but anyway, what about the length? How do we do that? So we've done we've done two different diameters. But we don't really care about that diameter anymore because we have that. We want to know how long is it from this tip to this edge. So far we've only done one thing. We've only measured by clicking one thing, and that's great. That's easy. But what about, a distance edge to edge? So SolidWorks is pretty smart. It's pretty intuitive. You know that you have to measure from this face. And from this face, we get some information, but we're not really interested in that. From this face, now we can go up to this edge, this point. And I don't know if it'll pop up. Oh, it did. Point to point, show Z. Yeah, so we've got this, and it even shows the location, which is nice, 0 and 0. So we know we're on the origin axis here, but that's not important. What is interesting is this distance. Now, we have a few different things pop up if we zoom out. Lots of information here. This is interesting because if you're a little bit, if you selected something that was off, say we didn't actually get the point, but we got a point right here. I can actually show you that point. Oh, I don't want to do that. Never mind. So say that I got the point from, right there by accident to this surface. We can see that it's not 18 inches anymore in our distance here. And it shows, this is kind of funny. I don't know why it's doing that. But you can see here that there's a lot of sort of decimal places. So something's not right, because when I designed this, it was a nice number. And usually you'll find when you're looking for things, they are nice numbers. So there are two measuring options here. We want to show XYZ measurements, and we don't want the point to point. Point to point is like here to here, and we have a distance of that. We don't really want that. We want to be selecting off of known features. So there we go. There's a good one. The vertex. We got the point there. You can also go and delete this selected selected face by clicking delete, and it leaves this one selected. And we go back to our edge. That one. And now we get this nice normal distance of 18 inches. So that's great. We got all this information here. We know that our delta Y, remember our coordinate system is right down here. So you can look delta Y, the distance or the change in Y is 18. So we know we are perpendicular. And then we have a couple other things, which is whatever. We don't really care. This just means that we didn't select a surface directly in line with the origin. We selected a surface that was off. So we selected something that was 1.95289 inches from that axis, which we know because that's what we did. So cool, we're done with that. Say we wanted to do another measurement, you can click the open space and it will delete everything. But awesome, cool. So now say that we want, we've got those two. We got the length, we got the diameter, we got two different diameters. Oh yeah, what about this distance here? So we can do, remember we have to measure off of surfaces because we want the normal distance, right? And there we go. So we selected those two faces. And now we have 5 inches. And you can see, yeah, no other problems there. So cool, all good. We got those things. We didn't screw up the part. We didn't do anything bad. Now, what about how heavy is it? Now, of course, this is designed in a computer, so we have to assign things like materials, weights, densities, all that stuff. But we did design it with volume. So we can apply a density and it will tell us how much it weighs. So knowing a density of material is pretty common. You can more or less look it up. We know the density of aluminum, of steel, carbon fiber, and fiberglass is a little more tricky, but that's why we have undergraduate students to do our testing. And so once we have those numbers in, there's a fancy tool right up here in the evaluation tab or evaluate tab. Right beside measure, there's mass properties. So click on that. Take a moment to think about what it wants to do. It's going to bring up this big honking box. And for the moment, since we didn't select anything before we clicked that, it's going to give us the master assembly. Now, here's lots of fun information here. Let's go through this for a moment. We've got a couple of properties of the master assembly, which we're not too interested in. This just tells us that it's in the default configuration state. There's not too much going on. Everything's normal. Here's our total mass. Now, just like I said, we have to assign stuff. So at some point, when you're incorporating things into the assembly, you do have to assign things like density to all of your components. Some off-the-shelf parts you download are easy to find, or they'll already have the mass in there. So that's cool. But this just literally sums up all of the components together and gives you a final mass. This is the volume. I don't know exactly what that means. I don't know if that's the like encompassing volume or if that's the volume of all the individual parts. But regardless, it's a value. Surface area, center of mass. This is nice. This only works if you have all of your densities and masses actually figured out. And then we've got principal moments of inertia, and some other stuff. I don't know what those are. But lots of information here. These are really helpful. These are super, super helpful for more advanced design that you'll get into later in your career, hopefully. But there's lots of really good information here. So say that we don't care about that because we don't really care. We're going to right click, clear the selection here. So now I've got this open mass property window. Now we want the nose cone. A couple of different ways, of course. We can select it from the tree, or we can just click on the component. If we click on the component, we got to make sure we're clicking on the right component here. So we want the assembly, right? We don't want the edge insert. So remember, we have a hierarchy of stuff here. We've got the nose cone assembly, and then we've got all of the stuff inside the nose cone assembly. So we've got tip insert, edge insert, fiberglass nose cone, edge insert. We've got a couple components in here. So we got to make sure that we selected the right one. That's why it's a bit nicer to go into here and to select them so that you're a bit more sure of what you're doing. So all of these things popped up. Great. We don't want those. We can just delete those. Now we have definitely the nose cone assembly. Where did it go? Nose cone assembly. Yeah. Nose cone assembly. Recalculate. Okay. Click it in here. Recalculate. Always, if you have a, yeah, there's some options here, but we're not worried about that. So we've got a few items here. Mass, 772 grams or 0.7 kilograms. That's great. That's what we wanted. That's exactly what we wanted. Again, I'm not sure about this. I'm not sure if this is the encompassing volume or just the volume of this object. 17 cubic inches sounds kind of like the volume of the object. Surface area, cool. Center of mass, sweet. All this other garbage, great. So now that we have the mass, we know exactly, we can close this. We have the mass, we have the distances, we have all this stuff. We're super happy. That's great. Now, that's awesome. Really good. We can exit the isolation. Give it a moment to think about what it wants to do. Oh yeah. Perfect. Amazing. Okay. So I'm going to hit Control Q and see if that helps. Perfect. So we don't care. That's okay. Okay. So if you ever have weird stuff going on, you can hit Control Q, which is a force rebuild, which means that it goes through and it just rebuilds all this stuff. It just goes and does everything like it did when it opened the file originally. Cool. So let's do a couple of helpful ones, because I know there was a couple questions on sizes and whatnot. So this is the one of the upper fuselage. So let's open this in the project tree here, and I'm gonna isolate it. Okay. Now we want to know the diameters and the lengths. So we've got measure here. We'll click our measure in our evaluate tab. Our isolate button. Let's get this out here. Evaluate measure, and we're going to go up to this edge and over to this edge. Oops. Cool. Now I've got face and a face, and look at that beauty. Cool. Lots of stuff here. Let's just look at this distance. And it's delta y is good, no x and z, so we know we are our square. Also says here the two selected items are parallel, which is nice. And there's our distance, so 59.5. Great. Click out. We want the inside. Make sure you are on the inside. Look around, have a peek. You can also make it not transparent, remember. But this tells us here, boom, 4.51. And if you remember, that's exactly what it was on the nose cone. So that's great. Perfect. So let's get out of here. Now let's go over to the propulsion assembly for the boat tail. So, hey, look at that. There's some screws for your boat tail. There's 3 of them, not 4. Wow, looks like someone has some CAD work to do. But here's our gap. So there's quite a bit of stuff going on. It looks like you're gonna have to make a thin. Yeah, interesting. So it looks like your air gap has to be about this big. Has to be, let's take some measurements. So I'm not going to isolate because this is kind of a convenient thing to look at because it's right on the end and it's on the outside. So I'm just going to look at it. So measure, open up that, click on this surface. Okay, go over to here. I've got diameter, 4 inches. That makes sense. I'm happy with that number. And I know I selected this, so that's good. So that's that parameter. Now, what about this height here? So I want to do, there's a couple ways, of course. I can select this edge. Oops. Oh no. Clear selections. I think I had it. There we go. Edge. Okay, 4 inches. And then I can go to this edge. You see, there's easier ways to do this, obviously. I can go to this edge. And our delta y, we look down here, delta y is 5 or 0.5 inches. Obviously, I would have just done this. There to there, delta y, normal distance, they're all the same. They're parallel. We know we're good. Cool. And then, of course, this is the nozzle. Remember, this is the diverging nozzle. So we've got diameter of 2.7, and we've got a distance from the original face, remember, of 1.735. Beauty. That's great. And if we wanted it in millimeters, which is nice too, we can go and change this units precision down here. You can go and change this to custom settings. You can bump this up to what, 25 decimal places. No, let's do 8. Oh yeah, beauty. Use dual units. Sure, why not? Inches. Heck yeah. Decimal places. Let's do it. Degrees. Yeah, I like to have precise. Lower. Accuracy. Higher. There we go. Okay. I'm prepared to wait all day for these accurate measurements. Look at all these decimal places. Perfect. When you're doing the measurements, look for the nice numbers, right? If you know, when you design stuff, pick nice numbers so that you're not questioning if this is the actual thickness or whatever down the line. And someone's like, why the heck is that super random? You know, obviously some numbers have to be designed and won't be friendly, but more or less you can pick nice numbers when you design. So try and do that for the sake of everyone's sanity. Cool. So that's pretty much that for measuring and whatnot and isolating. So that's pretty sweet. Let's see here. How long? Okay. Parts here. So let's say that you wanted to actually edit a part in here. So say that you're looking at this just to check if your nose cone fits and you're like, oh my gosh, it doesn't fit. There's a really silly thing right here. It's really important that you don't go in and just start sketching on this edge here, because if you try to do that, you start a 3D sketch, and you also start a sketch inside. Well, it doesn't have to be 3D. This one's a 2D. You can make it 3D, which would be even messier. But this goes into the assembly, which is not part of any of these parts. So you really have to be careful working in this assembly, because this will make everyone very sad, and it will also make me very sad. So please don't do that. If you need to go and edit a component, and I encourage you to open this and look at where your component sits and how it sits, and maybe, you know, discover, that's super annoying, that it's not the best design or whatever, but you want to have the ability to make that choice and go in and fix it separately. So say that you wanted to fix your nose cone because it's wrong. We find it in our tree. Remember, if we're way down here and we're like totally lost and whatever, we can just right click any of the things and go and find collapse items, and it will bring you back to the original space here. So we're gonna open a thing. Remember, isolate just makes everything else hidden. It doesn't do anything. So other than just make stuff hidden. So we can edit the nose cone a couple ways. We can edit it by going into assembly. So we were in evaluate, but we want to go back to assembly. We can edit it here. And remember, we just selected the assembly. So I'm going to edit the assembly. And this should gray everything else out, which it kind of did, not really. Like, fix my graphics maybe. But now we're in an edit component, and you can see it's a light blue. So this tells us we're editing the assembly, not any of the sub-assembly parts. So these are parts in here, but this is the actual assembly. So again, we would have to go in, if we wanted to edit just the nose cone, we would have to go and edit that. But once we have to get out of editing our assembly and go back into it and edit it. So this is kind of messy, as you can see with the hierarchy. You kind of have to go and find what you want. So sometimes what a better way to do it is, go back to your original thing, go find your nose cone assembly, right click, and I'm going to go to the very top here and open the subassembly. And cool, I'm not going to worry about that for now. But I just opened my nose cone assembly. So this is only the nose cone assembly, and you should find the title of this up here if your computer screen was a higher resolution, or sorry, if you had less zooming in. Okay, there we go. So now we have the nose cone assembly here, which is great. And again, we can right click anything and hit collapse items to bring us back to this nice thing. I don't know why it doesn't bring you to this originally the first time, but whatever. So now we're in this. And a same thing, we are in an assembly, so we can't go, don't do this sketch thing, don't do that silly garbage. Go to here, and you're going to click on edit component. And again, we have a nice blue space where we can edit the components. We can say, you know, go and edit this sketch, and we can edit this sketch. And now we have this sketch, and there's where the nose cone sketch comes from. And we're done with that. Sweet. Perfect. We're done editing. And yeah, that's pretty much that. And of course, we can go and open this part and work on this part as a separate part, which is, you know, ideal. But of course, remember, we've got so many layers here that we don't want to. Yeah, if you're just sort of screwing around, never save anything. Always hit do not save. So yeah, that's pretty much that. So say you've made your changes, whatever, you would hit save here, and then you would go back. You can close this, discard all for now. That's okay. So say you made your updates and you go back to your original assembly and get all these errors. And that's that. And then it should update your thing. And if you're having issues, again, you can hit Control Q, and it should rebuild it. You can also hit this button alternatively, but Control Q is a little bit more fun, I suppose. And I think it actually does a little bit more. I'm not sure, but Yes. So that's that. That's pretty much all I wanted to do. I guess one more thing is if you wanted to start screwing around and say you want to try doing this sketch and ruining everything, or you want to open this and drill a hole in it and look inside, do all this crazy nonsense without hurting the assembly, what you can do is you can do a pack and go. And this will provide a local copy for you. This is like a really I suppose robust way of sort of copying copying this and pasting this somewhere else. You could also just copy paste that to the desktop or somewhere else. Your GrabCAD, you could copy paste your GrabCAD folder to your desktop or wherever, and then edit it that way. But sometimes there's some dependencies and you get mixed up names and then you might accidentally edit stuff, and I don't know. This way is a bit more robust, especially if you have parts all over the place in your assembly or from different folders and whatnot. This really sort of cleans it up and keeps it in one spot. So you can save it to a folder. I'm going to save this to say my desktop. Yeah, desktop. And you can include the drawings if there are any, custom decals, all this garbage. Yeah. And I can't, oh, there we go. Okay, I can't actually see the bottom because it's too zoomed in, but flatten a single folder and then you hit save and it's copying all the files. It'd take a while to do this one, but oh, that's not too bad actually. Oh no, it's all on my desktop. Oh, this is terrible. I needed to put this in a folder. Oops. So make sure you actually make a new folder because now it's all on my desktop. Oh no. Oh goodness. Okay, well, that's okay. I'll deal with that later. And that's pretty much that. Also, I wanted to make a quick comment on how to save parts for STLs for 3D printing. So this is a 3D printed part here. This is part of the payload microfluidic sleeve. We're gonna go and select the part. Ooh, uh-oh, don't do that one. We're gonna select the part because we know what we want. We found it in the tree. Turns out it's actually a part. So we can open it here, open part, or you can right click the part and open it. That's fine too. And now we're in the part file. So this is a part file. So now we don't have assembly features or anything like that. To save this for 3D printing, we need an STL. So we have to do a save as. So save button, save as. Save it somewhere convenient. This is probably fine, whatever. And then your save as type, you're going to go to .stl, which is down here near the bottom. Okay, now there's a bunch here. There's something important you have to do here. Go into options. You can also do this different. You can go into your system settings up here with the little gear cog, but this is the same. So you have some options that you need to fix here. Right off the get-go, you're probably going to have some resolution that looks like this, and this is exactly what you'll get when you 3D print it, which sucks because this should be a circle, not a hexagon. So you want to increase it quite a bit, and we don't want this fine because we still have quite a bit of ways to go. We don't want to go to the end because that's crazy and your file is going to be massive. But what you can select is about here. Should be good enough. 3 degrees. This doesn't need to be too specific, but sort of near on the end here, and you'll get very good resolution. And you can hit OK. Preview before saving file. That's kind of fun. Sure, let's do that. If you're doing assemblies, don't do assemblies, just do parts for now. If you have big questions on this, I can help you later, but just focus on that for now. So I'm going to put this on my desktop because I don't want to screw anything up. I just want to show you. So this is our STL, and this is what gets output. So as you can see, an STL is just a collection of lines and triangles. And you can see here, there's this many triangles, which is cool. But yeah, you hit the save and great, cool. So that's how you save a file for 3D printing to making STL. So that concludes the skill dev for navigating the master assembly and gathering information from it. Yeah, if you have any questions, let me know. There's lots to learn, of course, and there's lots of ways to do things, as we talked about every time. But remember not to save anything. If you're screwing around with this, do your pack and go. But just to make double sure, you go back to your GrabCAD and make sure that there's no files to update, because you shouldn't have done any of that. So yeah, thanks everyone. I will talk to you later.